Hi everyone. Today we will discuss queue data structure. Queue data structure follows the principle first in, first out, or last in, last out. That is, whatever the elements that come first will exit first. Whatever the elements will come last that will exit last. In this video, we will discuss construction of the queue using arrays data structure and construction of the queue using linked list data structure. So let's get start. First we will discuss construction of the queue using data structure. So for that, first I will take an array. Suppose uh, the size is 3. I will take an data structure. Suppose 0, 1, 2, 3. The size here is 4. I will make front equals to 0, rear equals to 0. Then I will simply do two operations. One is enqueue and another is dequeue. So in enqueue operation, I will pass value to enter, and then if suppose this is a rare, and this is the this is a friend, and this is a rare. So at starting, if rare is equal to size, then that means the queue is full. Else we will take that array of rare is equal to, I will pass that value to this, and we will simply do rare plus plus. How will works means, first I will pass element, suppose 10. Then uh, array of rare, that is array of 0 equals to 10. Then now rare is not equal to 0, rare will be 1, we will do r plus plus. I again array of rare now is 1, so array of 1 equals to, suppose 20, I'm passing value 20. Then again rare plus plus, that is now rare equals not 1, rare equals 2. So until we'll go 3. When rare equals to size, the queue is full. This is enqueue operation. Now we will dequeue, that is we will remove. So in the dequeue, first, when is equal to rare means, uh, then we will print q is empty. Else else I will take dequeued element as array of front, and I will simply do front plus plus. So if you take elements 10, 20, 30, 40, first friend is not equal to rate, so it will go else part array of friend. So that is first it will remove the starting element 10, then it will remove 20, then it will do 30, then it will 40. So at last it will show the the queue is empty. So i will run this I will run this code. So first I will static final int size equals to 3, something I will take. Then I will take in the global array, I will declare new int size. Then I will take int front equals to 0, and int rear equals to 0. Now I will make the functions public void enqueue. I'll pass parameters. Then if ray request is equal to size, we'll print it as queue is full. Else we will take array of rare is equal to value. We will pass then rare plus plus. I will also take public dequeue function. So here if front is equal to red, I'll simply do queue is empty. Now else I will print dequeued element is array of front. Then also I will do front plus plus. In the main method, I will take first one object queue object is equals to queue. I'll simply take queue. Now uh, first we will do enqueuing the elements. Then I will simply do q dot enqueue. First I will pass 10. Then q dot enqueue 20. Q dot enqueue 30. I'll pass one more. Q dot enqueue 40. Then I will make do q dot dequeue. Again q dot dequeue. Again q dot dequeue. Again q dot dequeue. Now I'll run this program. So if you observe here, first enqueuing the elements, array bound exception. So we can give using array. The drawback is the size is fixed. So in queuing the elements, I have passed the 10, 20, 30. So the first element is 10, right? So the dequeuing also 10. The second element we passed is 20, so it came by second. So last we have passed 30, so that is came by the lastly 30. So when you dequeued again, the queue is empty. So it follows, it's showing first in first out principle or last in last out principle. The drawback of array is the size is fixed, but it can be overcome by using linked list data structure. Now we will discuss uh, construction of queue data structure using linked list. So for linked list, I will take here, first I will take one uh, front is equal to null, and rear is equal to null. If you're not clear with the linked list, I will put in the chords. Just watch it, construction of linked list. So then I will first I will take that class node. So there we will take int data and node nest. Then I will take front null, rear null. Then I will take first enqueue operation. So I will pass value. Then first I will make node. I will m- create one new node. That is a new node. So I will create one new node every time a year. Then I will simply take that uh, new node, that object dot data equals to value, and that new node nest equals to null. Actually the default also it will be null. Then for this continuation, if else, if front is equal to null, and rear is equal to null, then we will make that front rear equals to new node. Or else uh, we will do rear dot nest equals to new node, and also rear is equal to new node. So suppose if I pass elements 10, 20, 30, first 10 will come, the new node will created. So 10 data will be there, null will be there. Then after that front rear is already null, so I will make this new node equals to front and rear. So after I will pass 10 element. So 20 will 20 will come again. For 20 again new node will created 20 and null. So now this time front rear not null, so rear equals to rear dot nest. So here this is the rear side. So rear dot nest, it will point out to this one. Then again the new one will make, we will make as a rare. So that means it will be like, so first 10 will become, then 20 will become, then 30 will become. So this is the front. It will at starting it will be rare, then this will be rare, at last this will be rare. So it will connect, so like this the connection will goes. Now we will code the code that enqueue operation for linked list, and after we'll discuss the dequeue. So for that I will take first class node. Then I will take enter data and node type nest. Now I will take here node type friend is equal to null, comma rare is equal to also null. Now I will take here a function public void enqueue operation. So I will pass value. Then node, this is a new node, means it's just an object. Node new node equals to new node. Then I will do that new node dot data is equal to this value I will pass. Then new node dot next is equals to null. Now I will take if front is equal to rear is front is equal to null, and rare is equal to null means we will do front is equal to rare is equal to new node. Else I will take rare dot nest is equal to new node, and I will make that rare is equal to new node, and I will pass elements here. I will make one list main is main. So I'll write function enqueuing the elements. Then I will do here list dot enqueue. Will pass value 10, list dot enqueue 20, list dot the advantage of this linked list is we can take the size we want, unlike the previous arrays data structure. Now so whatever enqueue I will take now, I'll construct logic for dequeue also. No, so public void dequeue operation is, so when if front value is equal to null means we will simply take that queue is empty. Else we will take uh, so the last front, the starting is fronted front, right? So dequeued element is, I will take front dot data, and then I'll make front is move to front equals to front dot nest, so it will move to right side every time. And also if when front is equal to uh, null, I will take rare is equal to null, because we are checking, right, if front equals to null, rare equals null only for constructing purpose again. So I will run this code. So enqueuing elements, so I will take here dequeue list dot uh, dequeue and list dot dequeue and list dot dequeue. I will again make list dot dequeue. So I will run this code. So first I have passed 10, 20, 30. So first so it follows first in first out principle. So the first element is 10, 10, so it is dequeued first. The second 20 is dequeued first. The last element 30 came, so it is came out lastly. So at last again if you do, the queue is empty. So this is about construction of uh, queue data structure using uh, arrays data structure. You can you can pause the video and check the logic. The logic for construction of queue data structure using arrays data structures. So yeah, the problem is the size is fixed. It can be overcome by using linked list data structure. So this is the code for construction of queue data structure using linked list data structure. So we have enqueued and dequeued the elements. So this is all about uh, queue data structure.